All right, section 9.3, we're going to work on verifying trig identities. What does that mean? It means getting the left-hand side to equal the right-hand side. So here we have an equation here, and I've got something to the left of the equal sign and something to the right of the equal sign. To verify this is correct, we need to manipulate these expressions so that the left-hand side equals the right-hand side. And it doesn't matter whether you start with the left-hand side or start with the right-hand side, it makes no difference. There are certain tricks that you can use, very similar to the tricks I told you in section 9.1, but let's get started on this one. So one trick would be to get, so here's a trick, get all the same angles. So here I have assigned 2 theta, but notice everything else is thetas. Well, let's rewrite sine 2 theta in terms of theta. So remember, sine 2 theta, I'm going to stick it over here on the right, is sine, cosine, cosine, sine, cosine, cosine, sine, sine, sine. And so sine 2 theta is 2 sine theta cosine theta. So let's rewrite this, and I have a 2 sine theta cosine theta. Okay, that's my sine 2 theta times tangent theta. Well, next trick is to get in terms of all sines and cosines. I don't have a tangent on the right-hand side, so let's convert that tangent into sines and cosines. So I have 2 sine theta cosine theta times tangent, and that would be sine theta over cosine theta. Now let's keep going. Let's simplify here. My cosine cancels out, and I have a 2 sine squared theta. Oh, well, I'm still not looking like this, but I'm going, Ooh, Pythagorean's theorem. Now remember, Pythagorean's theorem is a sine squared theta plus cosine squared theta is equal to 1. And so that means that sine squared theta is equal to 1 minus cosine squared theta. So we're going to use your identities. So I have 2, and my sine squared, let's go, 1 minus cosine squared theta. And so distribute the 2 in. And in this case, my left-hand side now equals my right-hand side, and you are done. Here's another example. Cosine 3 theta is equal to 4 cosine cubed minus 3 cosine theta. Again, we're going to use the trick in that we've got a 3 theta here, and then theta's over here. So I need to convert that 3 theta to just in terms of thetas, okay? And the goal is to get the left-hand side equal to the right-hand side, or the right-hand side equal to the left-hand side. It doesn't matter which way you start. But let's go with this cosine 3 theta. 3 theta. I know that 3 theta is going to be cosine 2 theta plus theta, right? Because 2 plus 1 is 3. And so it's equal to that. And now we're going to use sine, cosine, cosine, sine, cosine, cosine, sine, sine, sine. So this is equal to cosine, cosine, sine, flip the sign, sine, sine. Okay? All that is that sine, cosine, cosine, sine, cosine, cosine, sine, sine, sine. All right, well, cosine 2 theta, we need to get in terms of theta, and I still have these 2 thetas here. So let's rewrite our 2 thetas in terms of just single thetas. Well, I know that cosine 2 theta, using one of those flavors for cosine 2 theta, is 2 cosine squared theta minus 1. Okay, we just did that, times a cosine theta minus, well, sine 2 theta, well, that's 2 sine theta cosine theta. And I put brackets so we don't lose that minus sign. And then I have a sine times sine theta. All right, let's keep going. I don't know if this is going to work or not, but let's keep going. So I'm going to distribute the cosine in. I get 2 cosine cubed theta minus a cosine theta. And then I have a minus 2, and I have a sine squared theta cosine theta. Well, let's see. Whoops, I lost my cube. There's a cube here. Cosine times cosine squared is a cubed. So I kind of have my cosine cube, but I have an extra term in here. This term, it doesn't look right, okay? So notice I have a cosine cube. Let me rewrite this right here. This was 2 cosine cubed theta. Well, the terms here kind of match, right? So this one we need to think about how we're going to manipulate this. Well, I need cosines, okay? I have only cosines over here, so I got to get rid of that sine squared. I know that Pythagorean theorem says that sine squared theta is equal to 1 minus cosine squared theta. That's straight from manipulating Pythagorean's theorem. And so let's throw that in. I get a 2 cosine cubed theta minus cosine theta minus 2. Okay, let's throw in Pythagorean's theorem here. Times cosine theta. Let's distribute these guys in. And I'm going to have my 2 cosine cubed theta minus cosine theta. Okay, so I have a minus 2 cosine theta. And then I have a minus and a minus. It gives me a plus 2 cosine cubed theta. And let's see where that leads us. 2 cosine cubed plus 2 cosine cubed is 4 cosine cubed theta minus 2 minus 3 cosine theta, and that is exactly what I have there. So notice in my plan of action, I got down to one angle, a single theta instead of the 3 theta, and 2, I had noticed I had only cosines on the right hand side, so I switched everything into cosines, and that was the trick. Here's another one. You have tan theta is equal to 1 over cosine theta minus cosine theta over 1 plus sine theta, and you are asked to verify this trig identity. So we need the left-hand side to equal the right-hand side. In this case, I'm actually going to start with the right-hand side, and the first thing I want to do is I want to find a common denominator. So that means I want to multiply the left-hand side by this 1 plus sine theta over 1 plus sine theta. And I want to multiply the right-hand side by cosine theta over cosine theta. So I'm going to get a 1 plus sine theta over cosine theta times 1 plus sine theta minus, and I'm going to have a cosine squared theta, because that's cosine times cosine there, over the same denominator. I am not going to multiply through that denominator. My hope is that something might cancel out, because we want to get we need to get a tangent theta on the left-hand side. And remember, tangent theta is equal to a sine theta over cosine theta. So notice I already have the cosine theta here. I got to think, oh, how am I going to get rid of that 1 plus sine theta? All right, let's keep going. I'm going to combine under one common denominator. There we go. Now, please don't kill any kittens here. You cannot cancel out this 1 plus sine theta because you're not multiplying in the numerator. You just can't do that, okay? Well, I need to get just a sine theta by itself in the numerator. So let's look at this. Cosine squared. I don't want a cosine squared in the numerator. How can I get rid of it? Well, let's use Pythagorean's theorem. I know that cosine squared theta is equal to 1 minus sine squared theta. Okay, that's manipulating Pythagorean's theorem. So let's plug it in. I get a 1 plus sine theta minus, don't forget your parentheses, 1 minus sine squared theta. And let's see what happens. So all over this denominator. I'm not going to rewrite that. So right now it's going to stay there. Okay. Let's see. I have a 1 minus a 1, so it goes away. I have a sine theta, and then I have a minus minus plus sine squared theta. And now I will rewrite the denominator. I'm almost there, guys. Now, up top here, I want to get to a sine theta. I see that I can factor out a sine theta, and what do I have left? That gives me a 1. Okay, sine times 1 is sine theta plus a sine theta, all over a cosine theta times 1 plus sine theta. Now that I am multiplying here. Now I can cancel out that 1 plus sine theta, and I get sine theta over cosine theta, which is exactly tan theta on the left-hand side.